This video is about polynomials, and it's a short video to give you some definitions about what a polynomial is and how to identify it and how to name them. A polynomial is an expression such as x to the power of 5 minus 5x squared plus 7x, or 3x to the power of 7 plus 2, or 1/5 x squared plus 2x minus 5. A polynomial may have any number of terms in it, but each term must have a positive whole number power, except the last term, which has no x's, which is a constant term. And it doesn't even need to have one of those. The term of the highest index among the non-zero terms is called the leading term. Its coefficient is called the leading coefficient, and the coefficient is the number in front of the x term, and its index is called the degree of the polynomial. So for example, x to the power of 5 minus 5x squared plus 7x has a leading term x to the power of 5. The leading coefficient is 1 and its degree is 5. A monic polynomial has a leading coefficient of 1. A non-monic polynomial has a leading coefficient other than 1. A constant term is a term that does not contain an x. So for example, in the polynomial 3x to the power of 7 plus 2, 2 would be considered the constant term. We can classify or name some different polynomials. So for example, a polynomial where the highest power is 1, so a degree 1, we would call that a linear function. A polynomial of degree 2, such as x squared plus 6x plus 2, they're called quadratic functions. A non-zero number such as 8 is regarded as a polynomial of degree 0. Polynomials of degree 3 are called cubic polynomials. Polynomials of degree 4 are called quartic polynomials. Polynomials of degree 5 are called quintic polynomials. And after degree 5, we stop giving them particular names and we simply call them degree 6, degree 7, etc. Polynomials can be written in this very formal notation that we have here, that I've circled in purple. We would tend to just simply write them in their more simplified form. So for our first example, we're going to state whether each of the following functions is a polynomial. If it is a polynomial, we're going to arrange it in descending order by degree. Then we're going to state the leading term, the leading coefficient, the degree and the constant term, and say whether or not the polynomial is monic. Okay, so the first thing we need to decide is it a polynomial? And we would say yes, it is a polynomial, and we would say that because all of the powers are positive whole numbers. The next thing we need to do is write it in descending order by degree. So p of x is going to equal minus x to the power of 6 plus x to the power of 3 minus 5x squared. Now we're going to identify the leading term and its leading coefficient. So the leading term is the highest power, so that's going to be minus x to the power of 6, and the leading coefficient is the coefficient of that term, which in this case would be minus 1. The degree of the polynomial is the highest power, so the degree in this case is going to be 6. The constant term, so we're looking for the term that contains no x's. There is no term in this one, so the constant is 0. And we're looking to see whether it's monic or non-monic. To be non-monic, it needs a coefficient other than 1. So it is non-monic because the coefficient is -1. Part B, we've got q of x equals x squared plus x to the minus 2. Now before we worry about classifying it and putting it in order of highest to lowest power, the first thing we need to consider is it a polynomial or not? And remember, for it to be a polynomial, all of the powers need to be positive whole numbers. So the x to the minus 2, it's a negative number. So this is not a polynomial. And that's where that question ends. If we have a look at r of x has a constant term 9/2 and another term just x, so this one is a polynomial. If we have a look at the leading term, well, if we put our polynomial first of all in order of degree, so it's going from the highest power to the lowest power, then we'll look at the leading term is x. The leading coefficient is a coefficient of x, which is just 1. The degree, the power of x is 1. The constant is the term that doesn't contain an x, so that'll be 9/2. And the coefficient of the highest power is 1, so we would classify this as a monic linear function. Part D is a little bit trickier. We've got s of x is equal to 5. Now remember that this is still classified as a polynomial, even though it doesn't have any terms that contain x's. We would call this 0 degree polynomial, so it's a special case. And it's written in order of highest to lowest power. The leading term and the leading coefficient are going to be the same. They're both going to be 5. The degree, we've already discussed that, is 0. The constant is 5. And we don't really classify these ones as being monic or non-monic simply because they don't contain any x's. Example 2 is a little bit different. It wants us to expand the expression. Once we've expanded it, then state the degree, the leading coefficient and the constant term. And hopefully you recognise this as following the perfect square rule. So p of x is going to equal 3x all squared plus 2 times 3x times 2 plus 2 squared. So p of x is going to equal 9x squared. 2 times 3x is 6x, times another 2 is 12x, and 2 squared is 4. So now we've got our polynomial is equal to 9x squared plus 12x plus 4. So the degree is 2, the highest power is 2 in our polynomial. The leading coefficient is the coefficient of the x squared term, which is just 9. And the constant term is the term without any x's. So that's the term at the end here, the 4. Part B is a little bit more involved, and you may or may not recognise that the last two terms, 5 minus x squared, 5 plus x squared, can be expanded using difference of two squares. So we're going to have q of x is equal to 3x multiplied by 5 squared minus x squared squared. So q of x is going to equal 3x outside of 25 minus x to the power of 4. So q of x is going to equal 75x minus 3x to the power of 5. So if we go for the degree of this, the highest power is 5. If we go then to the leading coefficient, the coefficient of the highest power is -3. And then finally the constant. Now there's no term independent of x, so our constant is 0. Don't forget to write that in, because it's assumed, or it's not assumed, that if you don't write down the constant that you're meaning 0. In our second last example, example 3, we're going to do a little bit of substitution. So we have p of x, our polynomial, is equal to x to the power of 4 minus 2x squared plus 10x plus 11, and we want to find p of 3, p of 0, and p of -1. Basically what that's saying is wherever you have an x in our polynomial, we're going to replace it with 3 in the first case, 0 in the second case, and -1 in the third case. So p of 3, and whatever's happening to the x is now going to happen to 3 in this case. So it's going to be 3 to the power of 4 minus 2 times 3 squared plus 10 times 3 plus 11. And if we expand that, 81 minus 18 plus 30 plus 11 to give us an answer of 104. So that's p of 3. If I do the same thing, but instead of replacing x with 3, I'm going to do it with 0. I get 0 to the power of 4 minus 2 times 0 squared plus 10 times 0 plus 11. The first 3 terms will all be 0, so p of 0 is just 11. And finally p of -1, so it's going to be minus, not 3, minus 1 to the power of 4. And remember that when you have a negative number raised to an even power, it'll become positive. Minus 2 times -1 squared plus 10 times -1 plus 11. So -1 to the power of 4 is just going to be positive 1. -1 squared is positive 2, but times by -2 will make it -2. Plus 10 times -1 will be -10 plus 11. And if you add those all up, 1 minus 2 minus 10 plus 11 gives you an answer of 0. Okay, now final question, example 4. We've got a polynomial, but one of the coefficients is unknown. We've got an a there instead of a number. But we've got a bit of additional information that's going to help us hopefully find that value. So we've got p of x equals x to the power of 4 minus 3x cubed plus ax plus 2. And we know that when x is equal to -2, p of -2 gives us a solution of 0. So I'm going to replace all of the x's in my polynomial with -2. So I'm going to have -2 to the power of 4 minus 3 times -2 cubed plus a times -2 plus 2 is going to equal 0. So -2 to the power of 4 is 16. -2 cubed is -8. Times by -3 will be plus 24. Minus 2a plus 2 is equal to 0. If I collect my like terms, I get -2a plus 42 is equal to 0. So -2a will equal -42, and a will equal 21. That completes our video on definitions of polynomials. Please attempt task 1 of the polynomials, and good luck.